Amanda Lacklen is the Senior Environmental Scientist 4 with the Office of Environmental Hazards and Toxicology with the Delaware Division of Public Health, Health Systems Protection Section. Amanda oversees programs ranging from radon gas to testing private wells. She is passionate about promoting educational awareness to prevent cancer on a plethora of fronts and speaks at community, regional, and national conferences and other educational outreach initiatives. Amanda sits on the Delaware Strategic Planning Committee for PFAS Remediation and the DNREC DHSS Fish Advisory Committee. Next, Todd A. Kaiser, PG, is the PFAS Team Lead, Hydrologist 6 in the Delaware Department of Natural Resources and Environmental Control, DNREC, Division of Waste and Hazardous Substances. Todd is an experienced environmental professional with over 25 years of service in the state of Delaware. He obtained his BS and MS from the University of Delaware and started his career at the Delaware Geological Survey, conducting groundwater recharge mapping and natural hazards assessments. Todd spent 15 years working through voluntary cleanup, enforcement, Superfund, and brownfield redevelopment projects statewide, and spent 10 years as a hazardous materials technician and specialist on the DNREC Emergency Response Team. He is the co-author of the Watershed Approach to Toxics Assessment and Restoration, WATER.
Thank you so much, Kate. Thank you. Sorry about that. Hello. As Kate said, my name is Amanda Lacklen, and I wanted to take a quick minute to thank a lot of people. First of all, Kate and the Delaware Academy of Medicine, thank you so much for agreeing to allow us to speak. The Delaware Public Health Association. This is the largest collaborative effort between the medical community, agencies from states, tribes, and territories on the topic that is PFAS. Also, Dr. Linda Birnbaum, I'm a huge fan, and you have a huge fan club, and you did great. I'm so excited. Thank you to my team from the Division of Public Health, the Delaware Department of Natural Resources and Environmental Control, DNREC, all of my sampling crews from both agencies, all our subcontractors, the homeowners that are learning alongside us, and my bosses, Marissa Jacoby and Sandy Spiegel. And now we are going to get started. Todd is sharing our presentation. So you've already gotten a lot of background about PFAS, how people are looking at it, how we are tackling this problem. So we are going to, although it's a heavy topic, and you might, if today's the first day you're hearing about PFAS and you feel overwhelmed, do not fear. We're blazing a trail forward here in Delaware, and we're going to give you some more details. Take it away, Todd.
Thanks, Amanda. Don't really have to go into many details on this particular slide because we've sort of had this presentation done multiple ways from our different presenters today. I think one of the things we want to take a look at specifically from this slide is PFAS is an emerging contaminant. It isn't as if this is emerging, it's suddenly being released. The knowledge, the information, the data sharing, all of this research and our collaborative work together is what's truly emerging here. So this is a map that's heavily outdated when it comes to the places where PFAS are detected. So I'll move into, first off, our cartoon we've created. In this cartoon, it speaks to a lot of the questions that were coming from the audience during the course of the previous presentations. In a conceptual site model, we're looking at different places where we know or expect PFAS to be present, how it cycles through the environment. And one of the challenging aspects of it that's been mentioned is its persistence. It's persistent, it's bioaccumulative, it's toxic. So it sticks around the environment, doesn't readily break down. And when it does, it transforms into other PFAS. It's bioaccumulative. When it goes into living creatures, it stays there. And then it's toxic. It does harm. So if you'll note on this particular cartoon, anything that is yellow is PFAS getting sort of back into the environment from some sort of operation, some sort of storage, some sort of way where PFAS is created, just disposed of, released. And then also there's the potential through the same sort of exposure pathways. The white buttons say this is where there's actually an exposure to humans, to plants, to ecological receptors. So we wanted to put this into play. And from that, look at places where we want to better understand PFAS's presence within the state of Delaware. So here, and I'm going to spend a bit of time on this, we're looking at how we have had multiple efforts across the state of Delaware to conduct sampling over the past more than 8 years, almost 10 years at this point. I'll talk briefly about our Division of Air Quality, which is doing air dispersion modeling, where we expect or know that PFAS has come out of air stacks. We're going to try to define that air shed, see where the impact is. We've also been sampling fish and game within the state. The idea behind that is there's potential routes of exposure for human consumption. It's in the natural environment, so we're paying attention to that. We've also taken a look at, and it has been mentioned before, several sites that are regulated through our Hazardous Substance Cleanup Act. So that's the Newcastle Air Guard Base, the town of Blades and their PFAS issue, the Dover Air Force Base. I could continue on. Those are sort of our highlights and the ones we've been discussing so far. It's important to note within the state of Delaware, through the Hazardous Substance Cleanup Act, we have listed about 12 different PFAS compounds as hazardous substances, which means we have regulatory authority to compel action related to the detection of those PFAS on certain sites. So we've been taking those actions. Other work that we've been doing, survey across the state, is to look at groundwater wells. We've looked at public water systems across the state, both in wells and in surface water. We have an ongoing study in our Piedmont area within Delaware, and I'll show that to you in a second on a map. We've been looking at surface water across the entire state, looking at fish tissue starting in 2019, and then doing a statewide survey across the entire state with the idea of where is it being detected, how is it being detected, and what compounds are there, and then can we track that back to a particular location. One of our biggest studies that's ongoing right now is biosolids and wastewater. So in 2023, we started looking at the permitted facilities, both soil, groundwater, and then also and adjacent property owners and private wells. So that's one of the topics we're going to spend a lot of time on today, is the concept of private water well sampling. Basically, the construction of the well is regulated within the state, but then the water quality is on that homeowner. So we put programs into place to assist homeowners within the state of Delaware, and we're working on expanding that program in 2026. So this is Delaware, if you're not familiar with it. By zip code, these are the clusters where we have more private wells. You'll note in the northern part of the state, the Piedmont area, we have fewer private wells because we have more public water systems serving water. But as we get down south into our more rural areas, our more isolated areas, we have a lot more private wells where we have citizens who are responsible for their own water quality. The program that we're putting into place is to offer sampling and mitigation when PFAS are detected. So as we're going through this presentation, you'll see items being dropped in our chat. One of the things right now is the Well Owner's Guide from the National Groundwater Association. We can't spend enough time here in about half an hour telling you everything we'd like you to know. So please look at these resources as you move forward. It helps you understand some of the topics that we're addressing, but then also some of the information that you may want to use when talking with your patients. When we do private well sampling, we're taking into account and building a conceptual site model there as well. If you have a private well, do you have a private septic? As we talked about before with some of the products concerns and the use within the home, which Amanda will expand upon, a private septic could be the source of PFAS to a well. Not saying it always is, but it's one of the things we have to understand. We also ask the residents, how are you using the water in your home? We've been surprised by how many people are still buying bottled water as if there's some sort of regulatory authority to that and that there's a guarantee that the water's better. If they have filtration in their home, we're questioning them about how long has that filter been in place? What was it installed for? Have you been maintaining it? And then through that whole process too, we're not just looking at PFAS as a concern, we're also sampling for standard drinking water parameters. And the idea behind sampling for standard drinking water parameters is that co-contamination could determine what next steps we take in terms of mitigation. So we're trying to gather data across the state in private wells while helping citizens also to best understand aquifer water quality for PFAS and standard parameters. So in your home, and we've talked about it before, ATSDR mentioned it, Dr. Birnbaum mentioned it, the idea of what should be filtered, should there be a need to filter PFAS out of your water? Primarily, we're concerned about that consumptive pathway, the use for cooking, the use for drinking, but we're also learning a lot more that some PFAS are volatile, so that could be an issue related to showering. We're still looking into that research. Coming back again to that concept of emerging contaminants, emerging knowledge, we're still kind of figuring this out. We want you to come on the journey with us. So when we're looking at private wells, we also want to take into account what nearby sources are there. Do we already have knowledge that there's some sort of source that we've identified through our cartoon that we showed before, where it would compel us to sample first? Also, what is in your home that you could be using that could be impacting your water quality, could be impacting your exposure to PFAS. We want to take all those things into account as we develop a site model for each of our home and residence. So before, the question came up, and it was a great one. It was a great prompt for this particular slide. This is what a letter would look like coming from DNREC and DPH to say, we've sampled your well for PFAS. Here's what we looked at. And through this letter, we're making the statement across the board that we're using the 2024 EPA MCL numbers as our action levels. First, for private wells and how we do our response, but then also Amanda will speak more to initiatives towards implementing that on an accelerated schedule within the state of Delaware. If you have a patient that comes in with this letter, this has come from us. Amanda will speak a little bit more about how these numbers and some of the blood test numbers correlate, if at all. But this is us providing information to each of the homeowners on what they should be doing next. So when we get this detection, we are currently set up within the state to talk about different options for treatment. Initially, our primary concern is the consumptive pathway. The bottom right of this slide shows an activated carbon system that could be installed under a sink, in a kitchen, bathroom, wherever water is used for consumption, to interrupt, to treat for it, and make sure that most of the PFAS that we can detect through our analytical methods, and I'll get to that in a second, are being removed. And we sample the raw water, and then we also confirm by sampling post-raw water, treated water, to be able to make sure that that system is still working. In an area where we have detections not just in one home, but maybe in multiple homes, we have to look at some longer-term options. So is it possible to interconnect with a public water system that in 2029 will have a responsibility to actually be treating and providing clean water free of PFAS, below MCL numbers for PFAS? That's an option. Another thing we could look at is a whole house filtration system, much larger system, much more treatment that needs to be put into place, and then much more maintenance over the course of time. Effective, but then there's that long-term responsibility. Could be an option we consider. We also look at the idea of putting in replacement wells. So if we were working with a public water system, we may recommend putting a well in a location away from the standard pump house or the existing well, if we can prove that the water is clean. If we're working with private well owners, we often recommend the idea of, and some situations can assist with, putting in a deeper aquifer well. If possible, we put in a confined aquifer well. And a confined aquifer well basically is a well at greater depth where there's a layer of impermeable material that basically provides a barrier for any of the PFAS that would be coming into the upper aquifer. Basically, drill deeper, find unimpacted water, and use that there. So through our sampling statewide, we've been able to determine that the confined aquifers in Kent and Sussex County are basically PFAS non-detect. It gives us a really good option for us to consider as we move forward.
All right. So here is a study that was conducted in Newcastle County, Delaware. This is the PFAS exposure assessment done by the Agency for Toxic Substances and Disease Registry, also known as ATSDR, as has been specified earlier. This study was looking at a lot of variables, but the biggest takeaway from this was that the PFAS identified in the dust in people's homes was also identified in the blood of those same people. So that being said, we started looking at how obviously a lot of people have eyes on the pathway of drinking water. But there are a lot of other pathways of exposure that we would like to have eyes on so that we can eliminate or reduce the exposure from those pathways. Similar studies will be soon available, so please keep an eye out for that. Next slide, please. So from that study came this poster that my team designed and made. We bring this to outreach events so that people can better understand how they can prevent exposure from these pathways. So the first one that I would like to point out is taking your shoes off before you enter the house. This isn't a product you need to go buy. This is something everybody can do. And if you already have this habit, then I applaud you. This is very hard for me. I always forget something and need to run back in and then take my shoes back off. But it is a good way to keep everything that's outside and not inside of your house where your loved ones are. Additional options on here, and please feel free to use this poster, or if you're in Delaware, we can come and we can bring the poster. So So changing out your air filters. This is something that you're already doing to make sure that your HVAC system's running well, your air purifiers are functioning well. Changing out those air filters is imperative to making sure that you are reducing the dust in your home. Using PFAS-free cleaning products, I'll get into products on the next slide. Looking at toilet paper, traditional toilet paper does contain PFAS, and when you rip it apart, you know how there's that dust that comes off? Upon switching to bamboo-based toilet paper, I saw a significant reduction in the dust in my home from that. Dental floss also contains PFAS, traditional ones. So switching to a bamboo-based dental floss with carbon on the outside, this is biodegradable. It's better for us. It's better for the environment. Washing your bedding on a weekly basis, making sure that your cookware is not harming you. So using cast iron, stainless steel, or ceramic cookware, that's a good direction to go in. Your food storage containers, making sure that you are storing them in non-toxic containers. This is imperative as well. Dr. Linda Birnbaum also mentioned fast food wrappers. So if I still eat fast food, if I get home, I'll take it out of the wrapper. So that way it decreases the amount of time that it has to leach into the food. This is one method you can imply. Next slide, please. So as we're working to educate people and promote healthier ways to avoid PFAS, this is another fact sheet. This is a question I get a lot. What should I buy? What should I not buy? And in 2025, at least 36 states have introduced bills targeting PFAS in product manufacturing. And when I'm looking at a product, I was overwhelmed when I first thought, I need to change everything. There's intentional and necessary. For example, these are products that we know it's in there. It's part of the process, and there isn't an option available right now, and we need this product, like a catheter, a lot of medical devices, electronics, gas-powered vehicle fluids, a plethora of medical devices, and winter jackets. These are things that we need, and yes, PFAS are in them, but it's unavoidable. The unintentional and unnecessary products are the ones that I'm really looking at. This is, and I might lose some of you on this, but waterproof mascara. I understand it might be beneficial, but do we need it? Is it necessary? Again, the dental floss, the toilet paper. There's a lot of advertisements right now that say PFOA and PFAS free. This confused me at first because why specify one PFAS? What about the other 14,999? So there's a lot of confusion and it can be very overwhelming, but I encourage you to reach out. There's a lot of resources. Resources will be dropped in the chat. There are avenues to figure out if you are consuming PFAS unintentionally. Also, as the consumer, you have the right, if you're buying a product, to reach out to the manufacturer and ask if this is in the product until we can get to a point where it's disclosed on the packaging. Next slide, please. So this is another fact sheet that it's a little easier on the eyes. This is a very overwhelming topic, especially if it's the person sitting in the patient's seat. So this has already been covered by several of the speakers. This is just one way to kind of break the ice and say, hey, these are some of the health concerns that might be affecting you that we need to address. And I'll speak more to health effects in a few minutes when looking at blood samples. Next slide, please.
So we'll shift gears here briefly to talk about analytical methodology. So we'll take a look at different ways that we've been sampling water within the state of Delaware, but then also a lot of human-made media. So first off, methods 533, 537, and 537.1, all designed specifically for drinking water. So not necessarily capable of dealing with some of the potential matrix interference that occurs when we do an environmental investigation. So very useful, and I believe they are going to be required for compliance in public drinking water systems. However, they've got a short list of compounds. We talk about 15,000, and then we're comparing 25, 14, 18. Kind of misses the mark a little bit, and even with our improvement by implementing method 1633 with 40 PFAS compounds, again, we're kind of missing the mark a little bit on it. However, with method 1633, which is an approved EPA method, we can look at wastewater, surface water, groundwater, soil, biosolids. So biosolids is the solid fraction of wastewater treatment, sediment, landfill leachate, which is the water that basically filters through and pulls whatever's in a landfill out with it. And then also fish tissue. And also we've done venison tissue using method 1633. So through this 1633 methodology, we're getting 40 compounds. We're attempting to expand what we're looking at and sort of understand where potentially one of some of these sources are occurring. But Dr. Birnbaum mentioned it, and it's sort of widely known that 40 out of 15,000 is not great. So there's other methodologies that could be employed to help us understand the presence of fluorinated compounds in the environment. One of which is the total oxidizing precursor method, or the TOP assay. And the idea behind this is not to get an actual detection of an individual PFAS compound, but to get an overall concentration of fluorinated compounds. And from that, if you do a comparative analysis between methodologies, say, method 1633 gave us this total, but a TOP assay is giving us a higher number. Really want to come back to some of the prompt questions from earlier on about destruction technologies. Heat it up and get rid of it. Okay, so if the methodology you're using, 1633, says that the 40 compounds you're concerned about are no longer present in something that you've thermally desorbed, you've destroyed in some fashion, a TOP assay could say, well, while that may be true, there are still fluorinated compounds that are potentially being released to the environment if not managed properly. So it's important for us as we move forward with this and just talk about briefly the concept of remediation, is that we kind of have two different topics. One of which is collection and separation of PFAS from whatever we're sampling and whatever we want to achieve. And then there's that destructive technology next step. How do you destroy the actual molecule? So a lot of times what we're doing is just basically separating and storing, separating and sequestering. So it's just something to be aware of. Now, I want to set you up here for the next couple of slides after I'm done here, where Amanda's going to take a look at the 9-panel blood test from an actual resident that we have. So at this point, there's other methodologies that are available for PFAS in blood, but this is what we currently have been looking at. So don't try to read this. This basically goes through and shows all of the different PFAS compounds that we're currently detecting through method 1633. And each of those columns shows the progression as we've added more compounds to it. There are specific colors here, and that's for a reason. We've taken the fact that we're looking at 40 different compounds, each of which, as a PFAS compound, have a specific structure, which Amanda will speak briefly to in a second here. The idea of each of these family groups, for any of the reporting we're doing through DNREC and DPH, this color is associated with these individual families. So when we put up bar charts and we take a look at different signatures, we're able to tease out some of the things we want to know about where a potential source area is in the environment. So looking at some of these compounds, they are considered terminal PFAS. They will not degrade any further than where they are. Some of them, the fluorotelomeres, also have a landfill signature. So if it's coming off of landfill leachate and getting back into the environment, remember that cartoon at the beginning about all the cycling. When we look and see particular signatures, it helps us track back to a particular source and attempt to cut off that source. One of our primary goals is identifying sources and eliminating sources. If we don't eliminate those sources back to the environment and then therefore back to us, the cycle will just keep continuing with these persistent compounds. It also gives us a vintage to some of our information here, in the sense that, excuse me, some of these compounds were created to replace older PFAS compounds, and apparently with lesser harm and lesser health effects, still having health effects and still being of concern. So just wanted to share the fact that we're looking at this as a commonality across multiple departments and divisions. And that's actually quite an innovative way of looking at things. PFAS has been a catalyst for us within the state of Delaware to collaborate that much more. Slide. Go ahead.
All right. This slide is why we are all here. Well, this slide propagated why we are here. Last year I was testing water, and 7-year-old female asked me to compare her blood results with her water results, and I was not able to do that. So I sought out to find the most intelligent people to speak on that, and I feel we have definitely accomplished that today. So I thank everybody for listening. So this is a 9-panel blood test, and as you can see, if you look at the linear PFOA and branch PFOA, I just want to acknowledge a differentiation between that both are being screened for. And if you look at the results, linear PFOA in this result was 1.19 nanograms per milliliter, whereas the branch PFOA was not detected. And then if you go a little bit further down and look at the linear PFOS and branch PFOS, that too was also a different amount. So linear PFOS was 0.62, whereas the branch was 0.26. So this tells me that my original theory of branch bioaccumulating more was incorrect. At least for this 9-panel blood test, the linears were bioaccumulating more. The most imperative part of this blood test is the NASEM recommended summation up at the top. So that is 3.21, as Dr. Linda Birnbaum referenced earlier. If you're under 2 nanograms per milliliter, you're probably in good shape. This patient was between 2 nanograms per milliliter and 20. So there are certain health effects that should be screened for. And then if you're over 20, that's the danger zone. So after being asked this, I asked my physician if she could, in Delaware, if she could test me for PFAS. And she said no for a few reasons. 1, that I was young and healthy. 2, that health insurance doesn't cover it. And 3, that she wouldn't know how to interpret the blood results anyway. So another reason for the creation of this CME was to get everybody on the same page, same book. This is at least one way we can test for some PFAS in the blood. And for references, at the bottom, this gray box, these are this resident's specific water results. So if as a clinician, you get one or the other, and the person is on a private well water, it would be monumental if you could encourage them to have their well water tested for PFAS. Starting in January, we're going to be launching a new private well program to continue testing for PFAS. We've already been doing this, as Todd was mentioning, but we're expanding. So anyway, this is the first of the blood test. Next slide, please. So this has already been spoken about too. My thunder has been stolen, and that is fine. I'm glad it was. I'm going to be talking about the carbon-fluorine bond. This is the strongest bond known to chemistry. I don't know if there's any other chemistry nerds out there, but organic was my favorite. And this is my least favorite bond. It takes a lot of energy to break this bond. So as Todd was referencing, yes, we can heat it, but then who knows if it's going up into the air and then back into the environment. So our best method right now is to filter it out for all the pathways that we know about, keep those filters until we know of a specific destruction method and a path forward. So back to isomers. So at the bottom left is a linear PFOA molecule. These are the ones that bioaccumulated the most in the previous blood result we were looking at. Then the 2 to the right, these are both branched isomers of PFOA. So the branching can happen anywhere on the carbon chain, and it just means that it is no longer long and linear. So PFOA has 38 unique branched isomers, and PFOS has 87 unique branched isomers. So on top of the fact that there's 15,000 different PFAS, most of them have isomers. So this is problematic. Another thing about PFAS is that most of them have a fluorinated tail and a polar head. So a non-polar tail and a polar head. So if it gets into water, think of it as like a bobber. So if the bobber, part of it is in the water and then part of it's sticking up, waving around into the air, because part of it likes water and part of it hates water. So it's going to stay away from it. Now imagine there's thousands of bobbers and it's coating the surface of the water. Now imagine that's an organ. Can you see where I'm going with this? And now imagine if these chemicals were vaporized and inhaled into our lungs. This is obviously a large problem. Next slide, please. So as Dr. Birnbaum mentioned earlier, the EPA was moving forward and has now decided to not press as forward or add a little bit more time. And Delaware is blazing forward. This is Senate Bill 72. and I thank the legislators that supported this bill. This is so that on January 15th of 2026, if a public water provider in the state of Delaware voluntarily screens for PFAS and has an exceedance, you're going to be able to see that on the Office of Drinking Water's website. By 2027, it will be mandatory to screen for these 5 PFAS that are labeled here. And by 2029, it will be enforceable to make sure that they are filtered out. A lot of public water providers have already been blazing the trail forward in testing and getting ahead of this. And I'm very proud of that. Very proud of Delaware for doing that. And that is on the public water side. As Todd mentioned earlier, we're going out and screening private wells. Private wells are not federally regulated, but we are making sure that if people have PFAS, they are being provided with a granular activated filter so that they can get started not having PFAS in their water. Next slide, please. Again, I know that all of this is very overwhelming, and I wanted to give some more resources. All of these resources are phenomenal. I would like to highlight the NEMA training. That is a 2-day intensive training. And if you want to get into the details of the chemistry that are PFAS, that is a good training for you. All of these trainings and all of these organizations are great in helping to blaze the trail forward for how to combat PFAS. There's research coming out every day to figure out what the best path forward is. If you have a patient that is on a small community water system, please reach out to the Division of Public Health. We have various funding grants and resources for people. We will also be blazing forward with providing nonprofits and other organizations to help educate their people on PFAS and figuring out how to educate the masses. Next slide, please. So that is it. I thank everybody for being here. I talk about PFAS more than anybody else wants to hear about. If you forget everything I've said, it will be recorded, or I'll tell you again, and that's fine. Thank you very much, and we'll answer any questions that are in the chat.
Yeah, there are a couple of questions. Thank you both. That was very informative. I appreciated getting the Delaware perspective from what we've heard from national folks. First question that came in said, as someone who eats a lot of fish and game, venison specifically, are there PFAS compounds found in these animals present in muscle or organ tissues?
I'm sorry. Could you repeat it?
Sure. As someone who eats a lot of fish and game, specifically venison, are there PFAS compounds found in these animals present in muscle or organ tissues?
So,
Todd, you're on mute.
I'm muted.
All right. Sorry, we're both in the same space here trying to figure out the sound. I think we just figured it out. So it's a great question. One of the things that we're looking at related to venison tissue is that through our sampling, we did not detect PFAS in any of the meat. So we did have a smaller subset of organs that we sampled. Some people consume the organs. The organs actually did contain quite a bit of PFAS, causing us concern. I think most of the information that would be something to rely upon, basically, the stuff coming out of the state of Michigan. They've done much more extensive sampling in areas where there's a known exposure to the environment and also to fish and game. So we don't have those numbers necessarily lined up here in the state yet. There's EPA numbers for PFOA and PFOS, recommendations only. Ideally, what we're looking at here, though, is just the concept of being aware of where you're hunting. If you know you're near a site that does have a PFAS release, maybe not be something that you'd want to consume on a regular basis.
Sure. And then there are a couple of questions, and somebody who asked that question said in the chat it was answered, but we'll just say it again so that we can make sure we say it out loud. Is the state paying for filtration systems or new wells for homes with elevated PFAS in their wells? And then as kind of a follow-up to that, is there an affordable kit for the general public to test their well water, or can people request their water testing, and where can they do that?
Unmuted.
So the
Okay,
issue
can
could
you hear
be
me?
if there's volume. Yeah, we got you.
All right. Thank you. The filtration is free. Please reach out to us. We are working on streamlining an online portal for people that want their private well water tested to be able to test for PFAS, standard chemical and bacterial drinking water parameters. I will say that it is imperative to screen for bacteria at the same time as PFAS, because if you do have PFAS and bacteria and then you chlorinate, the chlorine is going to fill up all of the GAC on all the surface area of the GAC. So you're going to want to test for both of them, remediate the bacteria, and then install the GAC to take out the PFAS. You can also install a UV light. Currently, we have DHSS has a private well assistance program. So if you're not able to afford to mitigate or test, the tests are free. And if you qualify, we can provide you with conditioning or filtration devices. And then, yes, the PFAS test is free, and we are ramping up production to make sure that we can cover the entire state, as about 20% of Delaware is on private well water. And we encourage everybody to test every 12 to 14 months. So please reach out. We want to come test.
Cool. There is a question about, does fluoride in water increase PFAS? I don't believe that's the case, but you guys tell me. I don't believe that
doesn't lower it.
Yeah. All right. That is all the questions we have for you guys. So thank you so much. All of the links that they mentioned are in the chat if anybody wants to look for themselves, and a lot of the things they showed on their presentation are also linked in the chat. So please feel free.